Right, moving back onto the clutch flywheel area. I mentioned earlier that the boss that goes in the middle of the crank needed turning down. So what I've done is I've had that done. So that's now a little bit thinner. And I've also had made up a new washer plate, if you can call it that. Here's the original and here is new. New one has a smaller hole in the middle, and the theory with that is that will sit over there with the bush in the middle, and that will stop it from falling out the end of the crank. That's the plan. So what I'm going to do now is mock this up on the end of the crank, slide the gearbox on, probably stick a small camera inside the gearbox bell housing, make sure that my small hole in the middle is not too small and that it's not touching the input shaft. The first thing I'm going to do, just to make it a bit easier, is take the flywheel off this backing plate, give me a little bit more view of what's going on. And this is the old flywheel, so I don't need it anyway. We have our bush and the phosphor bronze spigot bush. That'll go in the end of the crank there. And then our flywheel backing plate goes on, 7 bolts, all in a slightly different place, so it'll only go in one orientation. And then our new plate. That looks pretty good. Those 3 bolts should hold it. Just enough for me to put the gearbox on and have a look and see what's happening. Now the next question is, can I see in well enough? That lines up really nicely. The end of the input shaft is sitting nicely on the bush. So time to pull it off and put a new flywheel on, clutch back on, gearbox back on properly this time.
Unfortunately my mic died during this part. Firstly, I'm fitting my new to me flywheel, lining up the correct orientation on the 7 bolts and marking the new washer with a line against one of the bolt holes. Hopefully that will make it a little easier to line up the next time I need to take this apart. Then fitting the friction disc and cover. Usually you'd use a special alignment tool to make sure the friction disc is aligned with the centre of the crank, so the input shaft of the gearbox slides on properly and all the gearbox mounting bolts line up, but I don't have one, so I'm using a digital one. Digital, my finger, yeah, a terrible pun, I know. Once it's in line, I'm tightening up all the bolts, holding the cover to the flywheel just a little bit at a time, zigzagging around to tighten it down evenly. I was going to refit the gearbox after doing this, but I found another issue, which means that I need to wait for a part to arrive.
The next thing I want to do is fit a fuel pressure sensor. I've got a fuel pressure regulator here. This is a return system, so pump in the boot pumps fuel up through the fuel rail into the regulator, and then the excess fuel is bled back off to the tank. This is an AEM fuel pressure regulator, adjustable rising rate, so as boost increases on the engine, the fuel pressure increases. As the engine goes into vacuum, when cruising or off throttle, the fuel pressure decreases. In order to make the tuning and the fueling just that little bit more accurate, I'm going to fit a pressure sensor into the side, spare port on the pressure sensor, pressure regulator, and that will feed into my Link ECU, and that will use that as another calculation for how much fuel. So let's pull this blank off and put the sensor in. So here I have a adapter. So this will screw into the regulator, and then the sensor will screw into that. I put the rubber O-ring on. And there's a pressure sensor. There we go, and I'll wire that plug up later. Now the fuel pressure sensor is installed to the pressure regulator, it needs wiring up. The wiring coming up to the engine bay goes through 2 plugs on the bulkhead and into a loom here on these nice quick release plugs. So what I need to do is run cable from this up to the sensor. I've also got something else that I want to tweak with the wiring while I'm here. So first thing to do is untape this, pull this loom apart and expose the wires.
Time after time, you're always right. Wow. You never chase, yet hold me tight. Wow. Give me up, don't you mind it? Have we lost you and I cannot find it? Time after time, I think you lie. Let's get closer tonight.
Okay, so that's the first bit of the loom with the tape and conduit removed. So what I'm going to do is this fuel pressure regulator solenoid, which is a part from the original Mitsubishi. It's a safety feature. If the ECU detects any problems and it wants to try to save the engine, it will open up this solenoid, which will remove all the excess fuel pressure. It's just a good way of protecting the engine. The Link ECU, however, has lots more protection built into it. It doesn't need this, so this solenoid can come out, which means that I can repurpose this black and white wire, which is already run up towards the ECU but not attached to anything, and I can reuse that as the signal wire for my fuel pressure sensor. So let's strip this back out of the loom, more close towards the plug, and we need a 5-volt power and a ground for the sensor as well. I'm not going to cut this all the way at the end. I'm going to leave a little tail. I'll put some heat shrink over it, and means that I've got a 12-volt signal there should I need it in the future, and I can secure it up with the heat shrink. The other thing that I want to do while I'm here is replace the standard coil packs with these. These are Audi R8. They're well regarded as a high performance coil. So I'm going to be replacing the 3 original wasted spark coil packs, which fire both ways into one plug and then through a lead into another plug on the other bank, and replace it with 6 of these, which were running directly. Now, because of the ECU I'm using, I'm actually using a Evo 1 to 3 plug-in, not a wire-in Link ECU. It means that unfortunately I can't run fully sequential ignition, because they decided for some reason to use the 4th ignition output to hold the power onto the ECU so that it can do its shutdown procedure to reset the original stepper motor, which is used for idle speed control. So there's hardware on the circuit board that unfortunately I can't bypass, and I can't use that for ignition, which is a bit of a shame. Something I wish I'd researched just a little bit more before I bought. So do your research properly before you buy anything, and think for the future, what do I want to do? Because I'm now going to have to run these in wasted spark again. It's still not going to be a big problem. I'm not chasing huge horsepower from this engine, but it would have been nice if I could have ran it fully sequentially. It just means that the coil packs are firing half the time that they will be once they're running in wasted spark. So let's whip the original coil packs off and slot these into place, and we can then start to sort out the wiring to fancy new coil packs. Okay, so now the original coil packs and plug leads are off, we can start to install the new coil packs. So on this front or passenger side bank, they will just go in and they sit very nicely onto the plugs. But on the other bank, we need to take off the rubber bit, because whilst this cam cover sinks a lot lower, this one doesn't, so we need to just take that cover off so that it will fit nicely down the hole. So I'll get the other plug, the other coil packs, and let's get them installed. That's the coils on the plugs, and then got 6 electrical connectors for it. So I'm going to lay these in place roughly. And then I can start to lay out my wiring so that all of these are powered and got signal. Let's get some wire.